There we are. Sorry, I almost forgot to hit record. So we're going to be going through some of the common scenarios here where we run into these types of edge scenarios, and we're going to identify what is ultimately needed at the edge to provide each of the little pieces to make edge power, edge connectivity work. It's something that's easy to think that, it's easy to check off that box when really there's a lot of individual components that end up kind of making their way and getting that signal and that power to the edge device, and then all the way back to your NVR or your head-end server, wherever that's going to be. So we'll talk about how we can transmit that data a few different ways, get that video stream, that access control data back to your head-end. And then from there, how we get it for inside that building, on your main location, all the way back to your main server, your NVR. And then through that, we'll be identifying certain features that are going to help you from a maintenance perspective, and save you guys some time and money and repeat trips out to some pretty remote areas potentially. And also some tools that the customer themselves can use to keep on top of their network. So we'll be talking about that really through each of these scenarios as we're going through. So where are some common places that we tend to see this kind of need? I see it every day when I'm working with folks on our solutions team, coming in from cameras on a light pole, remote building entries, gates, solar fields, power substations, street cameras. I mean, there are tons of everyday outdoor scenarios that aren't directly attached to a building that introduce some challenging scenarios as we're trying to figure out that signal path, that connectivity, that power. So I wanted to go through a number of solutions that ultimately we can adapt to cover really any one of these that we run into on a day-to-day. To frame it up though, we'll kind of start by focusing around what I think is maybe a very common one for the average person on the call, a camera on a light pole. So when we want to put a camera in an edge scenario like that, I've got a pole in a parking lot perhaps, where I need to get power connectivity, I need to power that camera, get the video feed somewhere. Where do we start with our needs? I like to start by thinking about the most kind of baseline need. That camera's going to need power. How can I get PoE to this device at the edge? Well, to start off, that's going to be with a hardened PoE switch. So what do we need in our hardened switch? What does that even mean? Well, first of all, it means it's got a temp rating to be able to handle the outdoors. We need to size it, of course, for the port count that we need, for the speed that we need. Am I dealing with a single camera versus a group of cameras versus maybe some high throughput cameras like multi-sensor devices, things like that? And then individually, what power does each of those need? Do I need something that can output 15 watts, 30? And there's actually new high-powered standards, 60 watt and now 90 watt, that open up a whole new class of devices going forward. So identifying that need, how much power an individual line is going to need to be capable of, as well as that sum total of PoE draw. That's important too, right? If we don't size that PoE switch with the right total pool, well then as these devices are turning on or heaters are kicking on, stuff might turn off. That could be bad news. And then ultimately, one of the things we need to consider picking our hardened switch, do we want it to be managed or not? Let's take a moment and kind of look at the flip side of this and really focus in on some of the qualities of that switch that we were just kind of identified as needs here. A key one being temperature. You need something that's going to be reliable. EtherWAN, this is really their bread and butter. They cut their teeth on the hardened solution. They really are an industry standard when it comes to hardened products. They have a lifetime warranty on the EtherWAN product. So it's something that you can install once and not have to worry about repurchasing. And it's rated for the temperature range that you're going to run into in the field, anywhere from -40 degrees for folks like myself up in New England, where things can get a little bit cold, all the way up to 167 degrees Fahrenheit operational temperature. Think about that. You're putting this thing probably in a NEMA enclosure out on a pole, probably not climate controlled. So having something that's going to be able to bake in that enclosure in the sun to an extent is really a must, and something that should be a core piece of what you're looking at. The other thing too to think about that reliability, this is something that you're probably putting in a place that's hard to reach. So if it's up on a pole, that might mean you need a lift truck or something like that, expensive equipment to go and service it. It might be just somewhere remote where, hey, it's going to take a long time for a technician to go out and service it. So you'll want something that's not just going to be a failure or waiting to be replaced down the road. Now, on top of that, though, It's important to take into account the size of the opportunity that you're looking for. It's easy to think of a single camera on a pole. There might be applications where we've got multiple devices. Maybe it's a remote building that isn't climate controlled, storage space, things like that, that I need additional devices for. So we can cover anything, you know, as little as 2 PoE ports on up to 24 PoE ports and 4 additional fiber ports. You see on there 28 ports total. Maybe a power substation that's got a large group of cameras. Well, we need that type of high throughput, that type of high port traffic, high port count in a hardened environment. That can come into play in a number of scenarios where we just don't have that climate controlled space to put our normal 24 port switch that we might use inside our building. So now, once we've accounted for the size of our switch, we got to account for our power needs that we were talking about. Identify, 15 watt up to 90 watt with the new budgets that these guys have available. A key thing that separates the EtherWAN hardened product line from a lot of other stuff that's out there, it is security focused. So it has high PoE budgets available. When IT guys are dealing with this stuff, there's not as much PoE device permeation into the standard IT market that there is in security. So a lot of those guys can get by with switches that have maybe the ability to do 30 watts of PoE on a port, but only a smaller total of power because they're only going to power 1 to 2 devices off of that switch. They don't need to have full power for every line or every lead or port that's going to be on their device. We often do. On our end, it's the opposite. We're really pushing these things and now beyond 30 watt. So having that high PoE budget is going to be needed because you might have your multiple cameras. That could be a standard fixed lens or varifocal camera. It might be a PTZ. There's a lot of PTZs already on the market that have been using a 60 watt standard with custom injectors while that was actually being worked out as a standard for true PoE from switches. So that those 60 watt devices, you're going to be able to power off of this guy as well. That could be your access control components, of course. A lot of folks have, single door or multi-door PoE powered access control, and having 90 watt, I think you'll see more of that now with multi-door controllers having enough power to run their draw. You're going to see expansion beyond just security devices on this. A huge new market that this opens up is PoE lighting. A lot of this stuff, if you poke around the internet, a lot of your lighting providers are already having placeholders on their websites for this category of devices. Philips, for example, is one that I checked out. And they don't have any devices actually listed yet, but they've already got a section of their website that deals with intelligent lighting that's starting to have references to PoE devices and things like that. So it's really opening up a whole new class. And something I think is really cool is, let's say we've got a non-PoE device that wasn't designed for PoE because, hey, 90 watts is the brand new standard. There just traditionally hasn't been enough power for whatever that class of device is. Well, we can take this 90 watts and use a splitter. I can take that 90 watts and split it off so that I have 12 volt DC or 16, 24, or 48 at different amperages and a standard network jack. So now I can use that to power a standard DC device that's going to work with one of these voltages and come in under that amperage. So who knows what that ultimately opens up for you in terms of additional devices. Again, there's probably a number of existing devices. I think of like a 4-door access control panel that might be drawing 2 amps DC power or something like that. That really any of those new other DC devices are now have an option to be PoE powered more or less through an adapter. And then finally, we talked about that idea of managed versus unmanaged. WebSmart is a class that kind of sits in between. The idea for that is allowing some remote connectivity to be able to monitor or even just outright manage the programming of the network. A lot of times indoors, we just go right for that unmanaged switch because we're hooking up our cameras, we're hooking up our NVR. It's not really touching the rest of the customer network. So on the average install like that, there might not necessarily be a need for some of the more advanced monitoring and remote access. I would argue, though, anytime you can reduce truck rolls, I mean, everybody, it feels like, is installing remote monitoring capabilities to be able to go in remote desktop and service an NVR or an access control server. So having that ability to service your switches is just a natural extension off of that. And I think a really important thing to consider on any security job. But again, with these hardened devices, we're putting these out there in really difficult scenarios, difficult to reach. oftentimes as well. So again, whether it's up in a NEMA box on a pole that I need a lift gate or a lift truck to get access to, whether it's out in the middle of the woods at some remote station that we've got monitoring and we're wirelessly beaming that signal back sometimes miles to the receiving station, I don't want to send somebody all the way out there. If I can get on the network and monitor that remotely from a much more convenient place, that's going to just save you money in terms of your maintenance of this type of system long term. You can troubleshoot a lot of issues without having to actually be physically standing at the switch. So definitely consider that. WebSmart, which again is more kind of monitoring and basic controls, fully managed, allows you to do some really advanced stuff like separate your traffic. So we'll talk about things like that as we go through some of the more advanced scenarios too. All right, so we've looked at our qualifications for our switch and we're done, right? That's all we need. We've got power to our camera now. Oh wait, there's more room on this slide, so he must not be talking about something, I'm sure you're saying to yourself. And sure enough, an easy thing to omit, your power supply. Just like you need a hardened switch that's rated for the temperatures that you're working at in the field, this power supply is going in that same NEMA enclosure probably. So it needs to be also rated for the temperatures that you're looking to run it on. You need to have enough wattage for whatever that total pool, that total output the switch is capable of to cover as much as you're going to be using. Another thing you need to account for is derating. This is I don't know about dirty little secret of power industry, but it certainly was a secret of the power supply industry until I started working with EtherWAN. So if you take something away from this, one of the key items I'd like to relate to you is to think about this thing called derating. What derating is as you get to the upper operating limits of these power supplies, their efficiency drops. And it's going to affect different brands and different makes and models differently. You can have as much as 60% loss in wattage at the highest end of that operating temperature range. So what does that do to us? Well, when I'm chugging along at a warm day, a warm summer day in New England here at least, with my 200-watt power supply, I'm drawn close to that with my camera pool from my switch. Well, so far, so good, right? We crank up the temperature because this is in a NEMA box. It's an especially hot day, that thing's baking in the sun. In this case, still well designed. If this is the upper end of my limit, I'm just eking by. I've lost about 3.5% efficiency, but that 7 watts brings me awfully close to my ceiling of what I need for my cameras. And then ultimately, when it really gets hot, you see this thing starts to drop dramatically. Now I've only got 120 watts available. That means I have devices dropping out. I no longer have enough power for my switches that are out there in the field. Why do I bring this up? Not so much to scare you. I want you to be aware of it, but ultimately, this is the benefit of working with somebody who really is used to this space like EtherWAN. I had never heard of this before. This is something that now, when we're working with EtherWAN, I know to account for when I'm doing my jobs. When we know that something's going to be out in a especially torturous environment, we oversupply that wattage to make sure that even in the highest end of that operating range, we're going to be able to deliver enough power to power all of the devices that you have on that switch. And if you haven't heard of that before from wherever you've been buying any of your outdoor switches, you might want to question why that hasn't been brought up, because it's a very, very key element to be aware of when you're working with these devices. All right, so now we've got our switch, we've got our power supply, we've qualified what we need for that. We've got the right port count, power, the right wattage to supply, the power supply that's going to be able to handle the operating range. Now, we can start tucking those away into our NEMA box. And let's look at the next leg of this journey, which is our connectivity. I've got to get my signal from the camera back to my building. So let's start by looking at wireless connectivity. Wireless connectivity, really popular means of getting our signal there. Why? Well, it's convenient. It covers a lot of key things for us. It can have fast throughput, up to 866 megabits per second, almost a full gig, within a shouting distance of a full gig over a wireless line. So you can get fast throughput for multi-device configurations, multiple cameras out on that pole or at that remote building. You also don't need infrastructure between the two radios. I'm not running a wire. I don't have to trench or bury conduit or anything like that. It's a wireless signal. So long as it's clear between the two, I can get the signal where it needs to without any further infrastructure. And that can cover long distance. We have radios that can get a measure of their data across all the way out to 20 miles, depending on what your bandwidth need is. So you can cover a really long distance with a wireless solution. So that allows for really flexible deployments, right? So with our EtherWAN wireless radios hooked into our EtherWAN power supplies and wireless switch, now we can beam that signal back. But there are some things that you want to be aware of that you're going to need to make a wireless system work effectively. As I said, we need to calculate what that total throughput is. We want to make sure we're using the right radio pair and know what our ceiling is going to be at the distance that you're going. We want to know, hey, what do we need to power the radio that you selected? Some radios have their own power supplies. Some radios run off of PoE power. So depending on how that's set up, make sure it's a hardened power supply, of course, or make sure that we've got the adapter or the right PoE wattage that's going to power that radio. You got to have your mounting, of course, pole mounting or wall mounting. And you need to have a clear signal path. We're going to talk about the Fresnel zone. And I hope I said that right. You blame Google if not. And depending on what radios you get, you might need to do some pairing, some setup to make sure you've got the right sets of radios talking to each other for the signal path that you're trying to accomplish. Let's flip this over for a moment and talk in particular about a few of the needs and a few key things to be aware of when we're working with wireless connectivity. And again, some things that you may not have run into before. The first one I want to call out here is that Fresnel zone. The Fresnel zone is basically the signal path between the two radios. It is not a straight line. You cannot just shine a laser pointer from one radio to the other, see that the laser pointer hits the other radio and say, oh, all right, perfect, I've got a clear signal path. It's actually more to it than that. It's a 3D ellipse or orb between the two radios that needs to be clear. So the size of this area has a math equation that you see on the screen there. So what that does allows us to calculate how much open space we need around the center of that signal. What's the radius of that clear zone that we need? So it's roughly 72 times the square root of the distance you're traveling over 4 times the frequency. This is an easier calculation for us. We do our backhauls generally at 5 gigahertz. So it's the square root of your distance divided by 20 times 72.05. So we can help you with that calculation. It's not something that you're probably familiar with. It's something that I've actually worked with wireless radios before, and I had not heard of this, this radius that needed to be cleared. It was something that probably their engineers were working on the background, but wasn't getting communicated to me. And I've worked with some major brands of wireless radios that know what they're talking about. And so again, it astounded me a bit when I started working with EtherWAN and with their radios. They said, hey, be on the lookout for this. This is an important thing. What if we have obstruction to this? Well, that's where we want to have this, of course, as clear as possible to make sure we get good signal transmission. Now, there is some tolerance here. You can have up to about 20% of that area obstructed and still have very good signal. However, it degrades quickly after that. Once you get to about 40%, anything more than that is really going to impact the signal reliability and ultimately your throughput speeds. So we want to make sure that we're mounting these high enough to clear whatever obstructions might be in the way and have enough of that zone clear. Again, ideally, at least 80% of it for maximum throughput, maximum distance for this solution. So another one, if this hasn't been mentioned to you by the folks you're buying wireless radios from before, maybe something worth wondering why, as obviously this is a very critical element when you're setting these up and to be aware of when you're laying out that system design, knowing, hey, what is going to be the clearest signal path throughout these? Sometimes you might need multiple radios to kind of route your signal around a large obstruction rather than just trying to blast the radio signal through it, which is really not going to be successful. All right, so once you've got that bit clear, we know we've got a signal path that I can send wireless. Well, what's the right radio to get my signal where I'm going? Well, we've got a few kits to be able to help you with that. The first one I want to start you off with is probably the most everyday version of it. It's our EasyLink Bridge Kit. What's nice about this, it's for point-to-point. So it comes with everything you need at a minimum to get that system working. A pair of linked radios, they're pre-configured and tuned to each other, so you don't need to go through a pairing process the way you would with a more custom system. It comes with the pole mount, a little right angle wall adapter, so you can mount that and get a little pole mount to put it onto your building. And it comes with a basic transformer and a little power inserter to add that power into the radio. So this is one of the radio kits that would use a transformer as opposed to PoE. It does, though, have some additional options for that stuff. So no programming. What's nice about this too for setup, there's actually a signal display on the side of the radio. So as you're pointing them at each other, you're going to have an actual, an obvious signal strength reading right on the radio itself. So you don't need to go into any type of web GUI or setup to get this thing going. And then again, optionally, you have a true PoE adapter, so I don't need the transformer. I can adapt it for PoE coming off my PoE switch from that hardened switch. I can use a larger wall mount if I want to have more play in terms of mounting it. I might have to play vertically up and down. It's an 18-inch vertical pole to give you some more play when you're mounting it. And there's also an option for a hardened transformer. If you do want to use that still more traditional transformer, if it's going in a NEMA enclosure, or if it's going out at the edge, we have a hardened version of that that's available. We don't include that in the kit from the get-go because for folks who don't need that level of it, well, we're saving them that expense, but know that that is available, or we can just do the adapter to use the PoE coming off of your hardened PoE switch. So really just nice and easy kit to be able to work with. It's really meant to kind of replace your wire as close to or as minimal setup as plugging in your wire on either end. And it's going to be transparent to the devices that are talking through it. And ultimately, this can cover a lot of your everyday point-to-point scenarios. It can cover up to a 2-mile distance in terms of its total range. And in terms of max throughput, it can handle 300 megabits per second for a group of cameras, even some high throughput devices. That's quite a backhaul. So for a remote building that's got a group of devices, if we're under that 300 megabit throughput, a nice, easy solution to get that signal back to the main building. Now, of course, not everything you're going to run into is so neat and clean and point to point. I think a lot of scenarios will let you take advantage of a nice, easy kit like this. However, you're going to want to be able to do some more custom stuff too for more kind of advanced scenarios like we talked about beyond just that camera on a pole. So before I dive into the advanced scenarios, I wanted to talk a little bit about the more custom layout radios that we have available. This is our E-Wave line. So there's two versions of two different models. So we have one model that is purely bridge. We have one that has a 5 gigahertz omni antenna, gets you about 5 miles worth of distance between the two radios, and as well as a directional antenna that's good for up to 20 miles. So that sends out at a 17-degree arc and can hit multiple radios within that arc, or you can do point-to-point at a very, very long range at that point. Now, the other two radios that you see on my chart here have a little additional section for 2.4 gigahertz. You're going to hear me reference this through some of the more advanced scenarios that we go through. I love these options. This is something that I hadn't really run into before with point-to-point and other types of kind of wireless backhaul systems. The ability to have some local Wi-Fi for easier service. That way, again, I don't have to get up on a pole to plug into my switch maybe to get access to it. If I'm on site, well, maybe I can connect my laptop to that local Wi-Fi and now talk to the devices that are on that link and to be able to service them at that point. So we'll talk about maybe how that can apply to a few different scenarios. So let's peel that back and start off by looking at what I think is a common one that folks run into, particularly folks dealing with retail. Parking structures. You could think of it as just two multiple buildings across a campus is another way to think of this too. I've got two buildings that both have infrastructure and I need the ability to access both. So that could be a mall talking to my parking structure, multiple buildings across a campus, and I've got point-to-point links maybe creating that backhaul between these locations. Well, using the E-Wave product, you can get more than that EasyLink. The EasyLink is a very high limit, I still think, of 300 megabits per second, but when you really have something that's going to be high throughput, well, we can give you, again, near a gigabit backhaul, up to 866 megabits with ideal conditions. So you can get a high amount of throughput between the two, so great for these multiple camera solutions. So I've got maybe a pair of my 5-mile radios, or maybe they're really far away, and I'm like, probably not a parking structure at that point to be walking 20 miles to your building, but whichever pair of radios, in this case, I think a pair of the 5-mile antennas would be fine, or the 20 miles just to get us that full backhaul. And then we've got maybe hardened switches on the different floors of our garage, kind of get powering all of our devices, bringing that signal up to the radio that's sending it back to my main structure. So maybe my NVR is ultimately housed in my IT room in my main building. Maybe I have an NVR actually out in my parking garage. I have a little bit of IT infrastructure there, and I'm using this for a remote client connection to that device. So very common scenario for that high throughput point to point, and usually again involving other legs of communication to pool, you know, the data and power that all these other field devices are going to need and get that signal to the radios. Another common one might be point to multi-point, where I've got multiple radios talking to each other. So this might be example of, say, like a hiking trail. We've got a hiking trail across the valley. We've got these rest stations, you know, all along the trail. And I've got kind of a mixed use scenario here where I want to provide some security footage of these rest areas or these little, you know, step off spots that I'm setting up for folks. So if someone's getting trapped out on the trail, inclement weather, I can kind of have some eyes out on what's out there. And in addition, maybe I want to offer some Wi-Fi connectivity too. I don't have good cell service out there. If I can give some folks the ability to reach out for help via Wi-Fi, well, that's going to provide some added value for me when I'm deploying the solution. So we can use a pair of devices at this point. We use our multiple long-range radios here and the version that has that local Wi-Fi access hotspot. So from that head end of the trail, I can communicate within that 17-degree arc to all my different radios that I've got, have that signal, of course, communicated back, and each of them is broadcasting a blanket of Wi-Fi coverage as well, so that my guests can use that to reach out for help. Also helpful for the guy that's managing the head end. Even if, let's say, I wasn't using this to deploy Wi-Fi out along the trail, at the head end, I still highly recommend it, because now from a service perspective, when I go out to the device, out to service it, I get to the head of the trail, rather than have to go and hike out to wherever that device is that I might be having trouble with. Well, I can hop on the Wi-Fi right at the head of the trail and hit those devices, try to do some remote troubleshooting, and hopefully save me a bit of a hike myself. So in this case, you still have that really high throughput backhaul for your security. The individual Wi-Fi speed is going to be about 300 megabits per second on that end. And if you pair this with hardened with managed devices, at that point, you can even separate the traffic. So I can say, no, I've got a separate SSID and Wi-Fi spectrum for my guests versus the channel that's passing all of my security data. Just like a VLAN in a building, we can kind of enforce a VLAN out at the edge. And there are going to be some scenarios, again, where you're going to have some mixed use where it'll call for that. This is a really funky layout that EtherWAN worked on for a resort and dock. So this was, again, a combination where they wanted to blanket some Wi-Fi coverage in areas where traditionally might not have been available to them, as well as have a backhaul link for their security devices. So you can see here they were able to install the radios, in this case, again, the Omni antennas within the 5 miles, and be able to set up their signal path to go from the remote buildings of their resort, even from the dock out where the boats are, and have cameras there, have Wi-Fi coverage out there for folks that are docked, and be able to ultimately route all that traffic back to their base station. So this used multiple radios of long-range links and Omni antennas, some hardened switches to power those devices out at the remote buildings, out at my remote dock. And again, allowing that Wi-Fi is going to let you remotely manage that for remote troubleshooting. And if you went with WebSmart or managed switches, you'll have remote access to that layer of troubleshooting as well. Now, I talked about some of these antennas really having long range, and we certainly have experience in this type of application. A lot of times it's municipal, where we've got a number of buildings throughout a town. We don't have wireless or fiber infrastructure already, especially fiber infrastructure up here in New England. If it's not already laid, it's kind of hard to do that depending on what your area is, especially when we're talking about in the scale and the distance of this. So being able to link multiple buildings across town without the need for fiber, but also provide some redundancy. If this is emergency systems, well, we want to make sure that maybe there's multiple signal paths. So if for whatever reason, there's a break in a connection or some interference that we're not sure why that's happening, but ultimately is occurring, well, it's going to give us additional signal paths to still be able to access that data that's happening out at the edge. So in this case, multiple of our long range radios you see covering miles in between, and ultimately providing multiple legs so that we have 4 different locations that each have multiple backup paths, 2 different backup paths, and 2 of our locations each at least having a secondary path for that full linkage in case we have any issues between certain points. So it's still providing a very high throughput, even though we're talking about a distance of upwards of 7 miles at our longest leg. The average throughput across the system was still over half a gig, 650 megabits per second. And this is something where you can really lean on the expertise of EtherWAN. So we've got engineers at the factory that we can send these Google Earth layouts, let them know, kind of identify where our structures are. Of course, you guys are the local men on the street, so we want to make sure there is the ability to create that clear signal path, that Fresnel zone, make sure we can get the radios up high enough to clear any of those obstructions. Then we can, at that point, beam really long distance with high throughput for these types of connected towns, connected city environments, to be able to route that signal from multiple buildings spread across an area. All right. Now, unfortunately, there are going to be times when the convenience of wireless just won't be available to you, right? You won't be able to have that clear zone. There's just no way to get the radios high enough to clear the trees. We are going to have foliage in the area, or there's another building in the way, and I just can't really use multiple radios to hop the signal around that obstruction. I've got to find another means. Maybe it's because I've already got a very high speed function available to me. I definitely want to talk about fiber connectivity. I feel like it's something that scares folks a little bit because there's some cost to it, right? You have to bury it or have conduit for it. But when it's already available, or when it simply just is the need, if there's no way to again, provide that direct wireless connectivity, this really is a nice solution. It's high throughput, the highest, up to 10 gigs of data that we can submit through fiber lines. So certainly high throughput. Reliable. There's no chance for interference with those glass tubes. I mean, short of cutting the fiber line, there's really no interference to speak of. And it's very secure. You need to physically access the cable in order to try to interact with it at all. And it's not something you can just crimp onto and pull signal off of the way you can with copper. As soon as you do try to append it, you need to break the glass signal. So you're interrupting the signal to try to insert yourself in there. It's going to be very noticeable, the signal loss that drops because of that. And other things occur on that too. It's a very difficult thing to do, even if you're good at trying to attempt it. And ultimately, this is the longest distance solution, up to 43.5 miles, depending on the type of fiber and the frequencies that we're working with. So very adaptable to just about any type of install, so long as I can get the fiber from point A to point B. So once we've got our link, we're good, right? Well, almost. If you look on my switch there, I've got my hardened switch again, and I'm trying to plug that fiber into what looks like an empty port. Well, there is another device that's going to come into play. And again, one of the little things that you can miss when you're laying out this solution, having a hardened SFP device. This is your fiber adapter for whatever style and speed and type of fiber that you're working with. It, again, needs to be hardened. You can't take the same one that you're used to using in your IT closet, throw it in your hardened switch in your NEMA enclosure out at the edge, because it's going to have a much lower point of failure temperature-wise compared to the rest of the solution, and you're only as good as that weakest link. So the hardened SFP port, we want to make sure that it's going to match the temperature rating that we need, that it matches the number of strands that we have. We have solutions that can do transmit on one strand, receive on the other, so 2 runs of fiber, or we have ones that can transmit and receive on different frequencies on the same single strand. More expensive, but it lets you take advantage of those scenarios where there really is only one strand available. That's an option for you. When you're ordering it, you got to confirm the type of fiber. Fiber is really particular. So multi-mode versus single mode, the size of the actual glass in there, very important. You got to match that on both ends along with the same adapters. So you have to have the same speed adapters talking to each other on either end, 100 base speed or gigabit or 10 gigabit if you're doing really, really high throughput applications. And you got to match the right communication wavelengths for the transmit and receive, or else the 2 adapters won't be talking the same language to each other. So our SFPs actually exceed the hardened range of even our industrial switches at that point. So you see up to 185 degrees Fahrenheit for our EtherWAN hardened SFP adapters. Some of our hardened switches do have direct fiber termination and can be ordered that way. So there's certainly options for that. Again, we need to know all the particulars about the fiber. I really recommend looking at those SFP options, though. They might be a little bit more upfront in certain configurations, but you're also getting the benefit of being able to change them out if your needs change down the road. I can swap it out maybe for a gigabit one if I start adding more devices down the other end, or I can swap out my switch but leave my SFP adapter there terminated to my fiber line so I can upgrade my switch capabilities, just reinsert that SFP adapter with the fiber. So very, very easily configurable at that point. Again, the hardest part of dealing with fiber is just getting the fiber between the two locations. Once you have it there though, really, really great transmission to take advantage of. And again, there's some scenarios where it's just a must because of that high throughput, because of the distance that we're traveling, because it's critical infrastructure and we can't deal with scenarios where there's interference. So that having that glass completely, immune to interference at that point ends up being a must for certain jobs. Now, when all else fails, every now and then something is just so remote, so far away from the rest of our infrastructure that we can't possibly get fiber there, that it's just not going to be possible to do a point-to-point wireless because of obstruction or because we're exceeding that 20-mile distance. What do we do at that point? Well, here's where we start to talk about cellular connectivity at the edge. So EtherWAN has a hardened cellular modem that I could hook up to my PoE switch. It's certified for AT&T and Verizon. It's certified for high throughput so that you can pull multiple video feeds through it at that point. There's a 1-port and 4-port version available. There's also a really cool version that's FirstNet ready, which is a special transmission path and signal for cellular devices for first responders and critical infrastructure locations. So let's say you have a remote park or a hiking trail or something like that where you have emergency phones set up that are voice over IP, talking through 4G when they're activated back to my cloud or my IP phone host at my main building. And I need that in the event of wildfires or just, whatever might be impacting my cellular infrastructure in the area in general. I need those devices to take priority. So that's what that FirstNet is talking about. Probably won't be your everyday scenario, but an important thing to know that's available. And again, if we're dealing with security and critical infrastructure and emergency infrastructure, that's an important one to just be aware of and keep in your back pocket that's available to you. So what are some common uses for this? I kind of hit on that. Truly remote installs that there's just no other way to get the signal there. That could be remote access systems and gates. That's a very common one. That's nice because that's a low bandwidth application. We can use it to pull client video from a remote site. Maybe I've got a small NVR, handful of cameras I record locally, but I want to be able to access that video when I need to do a search or occasionally peek live at that site. Well, I can have a cellular modem provide that kind of as needed connectivity. I might be using that to link some of this on-site hardware to the cloud. Now, it's not ideal to have multiple cameras constantly transmitting through these devices. However, if you have just a remote scenario where it's a need, it doesn't matter whether you'd like to, you need multiple people to be able to stream video from this really remote site. Maybe it's a remote power station or something like that. Well, what's nice about pairing this with cloud is once I upload that video to cloud storage, all the folks that are trying to view it, they're viewing it from the cloud. They're not all hitting my cellular router to try to pull multiple copies of that video and just kill my data plan. So while not necessarily ideal, sometimes the cloud ends up being that point of broadcast where, all right, I've got to upload it at least once to the cloud through cellular, but once it's up in the cloud, everyone who needs it is pulling it from the cloud. I don't have all this data constantly, extra feeds and extra copies of this video flowing through my cellular subscription. So ultimately, those are the kind of gotchas with cellular. It's kind of similar to your normal phone, right? You want to make sure that you're avoiding constant video feeds if you can. Because any data that's sent is going to affect whatever service plan that you've contracted for the SIM card that you're putting in here, as well as really high bandwidth applications. Because ultimately, the more that you're pulling, there is ultimately an upload limit for these cellular devices. It's going to depend a bit on signal strength, so it's hard to give you a perfect number that's going to work for each area. It's really working in tandem with the local cell providers to help figure out who's maybe going to have the best coverage for where you need to put this and who's going to be able to get you the best rate on the data that you're pushing through the cellular radio. But this is something that's hardened, again, built for edge, harsh environments to be able to handle this type of connectivity. All right, so the last leg that I said we would get here, I've got my signal back to my building. I got it there, whether it was from wireless, point to point, bouncing it around obstructions through a long fiber run, or via 4G, I can at least remotely access it from my building, from my client software maybe. Now, hey, I've got a whole other network in my building that I need to build out to ultimately get the rest of my on-site devices, my cameras, my access control, my voice over IP phones, IP intercom stations, soon to be PoE lighting, as again, Philips and others are fast tracking development of those types of devices. So it's nice to have solutions for the interior as well. Well, I definitely want you thinking EtherWAN for all of your hardened applications, but we can cover you on the inside too. So again, considering what's the PoE standard that I need? What is the total wattage that I need? This is really where, if you've dealt with IT switches, they really cop out and they'll say, oh yeah, you can do 30 watts on any port, but it maybe only has enough total watts to do 15 on half the camera ports. Well, that's not going to be helpful in a security scenario. So all of our switches are rated at a minimum for the indoor commercial switches, a minimum of 15 watts per port simultaneously. Many of the smaller form factor ones like the 8-port actually just 30 watts per port on every port. It has that capability. You need to know that the uplink speed, if we're summing a lot of devices, is a 1 gig backbone good or a 10 gig. This is where a lot of folks, if you're just looking at, if you're not paying too close of attention to the switch you grab, you might grab one that is 10-100, doesn't have that gigabit link. I've actually seen that bring down entire security systems with one bottleneck now causing a whole slew of cameras on the other side of it or other devices to not respond properly and be slow or buggy or drop out or miss key video when there's motion going on. So being able to qualify that, properly identify that, those are our go-to models for the indoor, having a gig backbone. And if you need fiber connectivity indoors, again, for that 10 gig, you got to have fiber. Well, we can identify that, supply the right SFP adapter. So we got you covered anything from 8-port up to 48-port, really high density applications with lots of PoE available so that you're not going to overwhelm that 48-port with a lot of cameras on there. And then ultimately, again, just consider that management level. This is interior where I feel like a lot of folks skip over it. And again, depending on the scenario, you might be right to do that. But just at least consider that, again, feels like all the time now we're doing remote monitoring of these devices, whether it's our cameras, whether it's our NVR, where I want that team viewer or log me in or remote desktop to be able to get into an NVR or an access control server and do remote troubleshooting from offsite. Hey, if I have management of my switches or web smarts, well, I can use that and maybe save a truck roll and say, oh, you know what, I just had to cycle power on this PoE port to this camera, and now everything's fine. Well, that's going to be much more efficient than send somebody on site to unplug and plug it back in and be able to tell you the right port to even do that. So you can save some remote truck rolls with remote troubleshooting. And you can separate traffic. If they're big networks, if we're cohabitating networks, maybe I'm going to have my voice over IP phones and my access control system and my cameras all through the same switches, but ultimately I want them each in a separate network so there's no crosstalk. It's going to make it a more secure network, minimize any hacking capabilities or things like that, perhaps, knowing that there's a need for that so that we're selecting the right level of management in the switch that's going to be able to execute it. Now, one last thing I wanted to show you guys before we wrap up and we get to the questions here. Let's talk about some a bit more advanced monitoring than even just that. So again, WebSmart switches, managed switches are going to have web GUIs that you can go to that switch and manage. But there's a whole slew of our EtherWAN switches, both hardened and indoor use, that are qualified for our eView web monitoring. So eView is a software package that the customer would deploy. It sits on a server or a virtual environment, and it basically is their one web server for web management of all of their switches that can be connected to the platform. So there's a number of both WebSmart switches that you can monitor, as well as fully managed switches that I can actually see the activity on and control things like my VPN and things like that. It lets me do bulk configuration. So if you're managing a lot of remote managed hardened switches, well, I can have one place to do batch changes to how my network is deployed. And it's ultimately formatted for whatever device you have. It's a web page, so I can view that from my laptop, tablet, mobile phone, anywhere I have access to be able to get to that eView server. It's going to be able to feed me the full status of my network. And I can even set it up for live monitoring. So it's going to actively alert me when one of my switches drops off or when I'm having PoE issues. Maybe it's going to let me know that, hey, I'm having a derating issue because I've had a number of cameras dropped out and I'm getting a PoE alarm on one of my switches. So it can give you some really handy information to be proactive about managing your network. Again, a big network, critical infrastructure, mass transit, public works, things like that need to stay running. This is a way to keep eyes on a very large network, or proactive even on a small one. We do that for our NVRs, right? We want to set up alerts for cameras dropping out. On my access control, I want alerts for doors forced open, things like that. So that's a key piece, of course, to be able to have on our network as well. Otherwise, you're missing out on a whole host of benefits. So it's going to give you a visual representation of your connectivity, how your PoE is being managed, and ultimately how your traffic's being routed if you have the fully managed switches. Now, we've scratched the surface on a lot of stuff to be aware of and really to highlight for you all the little pieces that you might not think about that go in getting that video from that camera, from the pole, all the way back to your head end. However, that signal transmission is getting there. To dive deeper on any of these, visit academy.etherwan.com. It's a free resource, sign up. They've got a ton of tutorials for everything from kind of 101 items to go through the basics of these different topics, hardened switches, transmission methods, things like that. So some really advanced topics like, hey, here's how you set up a virtual LAN on one of our managed switches. To have that knowledge, whether it's going to be working with ours or others, I think it's really worthwhile, even if you haven't worked with our devices before, to check out the items that they have on there. Again, they're free. Just sign up for a account on there so that you can view and track status of and go through a whole bunch of tutorials of different levels for all sorts of topics. And they're adding to it all the time. I actually just saw, I got an email over the weekend, they added a new one on the cellular modem. So I was actually peeking at that, putting this presentation together and adding a little bit to it over the weekend here. So it's always being updated with new events, and they'll occasionally do some live sessions themselves too. All right, guys. Well, that is the end of the content. As I said, I wanted to leave a little bit of time at the end to go through the chat here, deal with any questions that folks had maybe run into or had popped up. I'm not seeing any that maybe got submitted through the chat along here. So I do have the mute control off, I believe. If you want to submit anything now, or if you want to unmute yourself maybe to ask a question, I'll leave everything open here for a few minutes for folks to find the mute button. If you're like me and I mute on my phone and on my speaker, sometimes I need to hit multiples before I can talk. I'm sure there's some IMI guys on the other end chuckling. They know it's true. So folks, if you have any questions, please submit them via the chat if you haven't had a chance to do that already. If you have, I apologize. One of the IMI folks just let me know if you're seeing them and not me. So great question here. Do we optimize wireless signal based on distance in advance? So that's absolutely part of what we want to consider from the pre-sales perspective. We need to know ultimately what is the distance you need to traverse and the throughput so that we can match the right pair of radios with the right antennas that are going to give you that level of throughput needed at distance. Now, there's a chart for each of these radios that kind of shows the roll-off at that point, but frankly, rather than just kill you with all the technical signal paths and things like that, that's something I would really put upon you to reach out to the IMI team so that we can get involved with the project and help you suss that out, along with the EtherWAN inside engineering team, folks like Gil and others over there that I work with all the time when I run into this as part of solutions that we're designing with NVRs and things like that. Here's a question. So the rugged switches that are powered by 24-volt DC for battery backup purposes on remote cameras. So we don't have built-in battery backup as part of the switch itself, but you could certainly have that as an element going to your device. So we do have transformers that go from 110. We have transformers that are DC to DC to power these switches. So depending on how you've set that up or what your need is for that, let us know, and we can incorporate from our end the right feed so that you're feeding the battery is ultimately feeding our transformer perhaps, or have the right signal path from that end too. And we've had to do that with some custom jobs. So we don't do things like solar panels and stuff like that, but given our presence on the edge and in remote areas, we have jobs out there where, hey, it's a camera on a pole powered by a solar panel that's on that pole going into a large NEMA box with batteries and a transformer that whoever's supplying that solar is providing. And ultimately they're providing enough battery backup and enough incoming power for our transformer and for our switch. Or sometimes our switch will then go off of their transformer perhaps. And again, we can be involved in those discussions to make sure all the particulars are met so you're not going to run into issues. Great question, because yeah, battery backup, especially if you're doing something like solar, power charging systems, where you might have power at the poles only at night for certain light pole systems. Absolutely, we've got systems that tie into that. So we don't supply that end of it, but we have a lot that deploy in tandem with that. Excellent. Any other questions? Give folks a few more minutes to type in or to unmute if you want to do it that way. All right, guys. Well, I'm going to keep it open here till 11, so I'll keep it open for another 5 minutes if folks are already dropping out. Thank you so much for spending the time and joining, and thank you to the IMI team who you guys work with. I'm sure that's how you heard of this event coming in. So any follow-up that you have, I want to thank everybody who changed their name. Hopefully somebody on the IMI side was able to grab a screenshot of the participants so that I can send out an email to folks with a link to the recording of this presentation, as well as send you some helpful links to the EtherWAN Academy, to some resources on the EtherWAN site as well. And you can always respond with any questions that you think of, through the day, over the course of the week, or when next time you run into one of these opportunities. Please reach out to us at the IMI team. Happy to help out. And we got local guys that can go out and visit these remote sites with you as well. So I'm going to hang on here. Again, if you guys have any questions, please feel free to submit them via chat. And thank you again. All right, we have another question in from... Sorry about that. I was monitoring on my tablet. Somehow the audio started back up. So we had one more question from Gene here, who wanted to know, do we have a unit with frequencies that allow for more foliage in the Fresnel zone at shorter distances? Great question. And in terms of how certain types of foliage or amounts or density is going to impact certain frequencies versus others, 2.4 versus 5 gigahertz. Certainly, the stronger the antenna, the more it's going to be able to push through that, but still to limited effect. I think that's one where it'd probably be best to deal with a particular scenario that you've run into. But that's one that I'll try to take offline with some of the EtherWAN folks, see if maybe there's some amount of general guidance that we can give with that. But in general, we want to try to keep, again, as much of that zone clear as possible, at a minimum 60% clear. That zone really isn't all that large at shorter distances. We're usually talking of, feet at that point, not tens of feet even. So a pretty narrow cone in a lot of applications. So we can help figure out what that zone is, and then ultimately, if it is going to be some difficulty, maybe then look at more high-powered radios or radios that we can turn on and off certain frequencies to maybe adjust for that. But ideally, we can try to clear it. And thankfully, again, for shorter distances, if the buildings are nearby each other, you don't really have all that wide of a Fresnel zone to deal with anyway. So Gene, I'll try to follow up with you on that one, see if I can get any other kind of general guidance on that for you. All right, guys, it's about a minute till, so I'll call it at this point a little early again. If folks have any questions, please reach out to us. You can reach me at events@inmarketing.com, would have been where you got your confirmation emails for this event from. You can reach me at davidb@inmarketing.com, or just reach out to your local IMI guy, because especially if you're working on a project, they're going to want to be involved with that to help make sure all these little parts and pieces are accounted for. They can help you do site walkthroughs and things like that too, to figure out, beyond just your network, all the actual devices that you're going through as well, with our cameras, NVRs, other devices, emergency phones, again, whatever your need might be at a site. We have the luxury of dealing with a lot of complementary technology here at IMI. So definitely get your local rep involved, and don't be afraid to reach out to us here in the office if you have any other questions as well. So thank you, guys. I'm going to stop recording and shut down the meeting. So thank you again so much for joining. I do appreciate it.